entire one, this is nothing but a controller. Here I am using, this is a PD controller, sorry, it is a PI, okay. Yes, I'm using first, let me start with PD control, because total response is combination of, assume it is the first waveform of that steady state. Let me talk about the transient response. This is the PD controller. So if you remove this one, this is called general standard second order system. Let me introduce one page. Now we'll start with controller, without controller. With controller, without controller. Let me start first without controller. Without controller. How we are going to increase the zeta, we will see by comparing these two. Without control means a general second order system. It is a summing point. General second order, closed loop second order system. Taking the block diagram first. Block diagram. So omega n square divided by s into s plus 2 zeta omega n. Then it is the output C of s. This is input R of s. Assume feedback is negative feedback. That unity. H of s equal to 1. Signal direction is very, very important. Okay, now. So in this case, H of s equal to 1. Let me make a difference between these two. So if it is, this is the standard closed loop transfer function system. This standard closed loop system, then open loop transfer function or a block diagram. Open loop transfer function is given by G of s, H of s. In this case, H of s equal to 1. Here it is unity means H of s equal to 1. So G of s means forward path. Whatever the gain in this forward path, we have to consider the entire one. This is a G, H of s 1. So you will get a omega n square divided by s into s plus 2 zeta omega n. So what is the type number? So if you type number is always dealing with the open loop transfer function. Type number. Order means closed loop transfer function. If you want to talk about type means I require open loop transfer function. If you want to talk about order of a system means I want a closed loop transfer function. So in this case, type number means s power j. I gave the explanation also. Number of poles at origin. Number of poles at origin. This is the origin. If equal to the denominator to 0, s equal to 0. One pole at origin. So its type number is 1. Type 1. If you use controller, the type number is increasing or decreasing. To compare that one, I'm taking the what is the type number. If it is without controller, type number is 1. Then what is the KP? Positional error constant. Formula you know, limit s tends to 0, G of s, H of s. If take that one, limit s tends to 0 and omega n square divided by s into s plus 2 zeta. Anyway, derivation part is not required. If replace s equal to 0, something divided by 0 is infinity. So I got Kp equal to, let me make it as a bracket, within bracket. Kp value I got infinity. If Kp is infinity, what about ESS? Steady state error for step input I'm talking. A by 1 plus Kp. Now A is the step input magnitude, 1 plus infinity. Something divided by infinity means 0. Yes, I got steady state error without controller. Yes, for step input. Steady state error 0. Next one, assume it is a 2. This is the first. Next, I'm going to check third one. K suffix V. Velocity error constant. Formula limit s tends to 0. S into G of s, H of s. Yes, I'm taking that G of s, H of s here. Limit s tends to 0. S into G of s, H of s means this is G of s, H of s. Omega square s into s plus 2 zeta omega n. Yes. Free place s equal to 0. Anyway, but before that one it will get cancelled. You put s equal to 0, this is a 0. Then remaining term is omega n square divided by 2 zeta omega n. Omega, it gets cancelled. Finally, we get omega n by 2 zeta. Now, fourth one, what is the steady state error? ESS for ramp input. A by kV. kV. A by kV. That equal to A by omega n 2 zeta. Check it out. Error is not 0. In this case, error is not 0. That means if we assume for some input, otherwise because it is a ramp input, it is a step. Assume ramp input as assume ramp means passing through the origin. This is a ramp input. If your output is like this, assume it is a steady state output. There is some gap between. It is an input, it is an output. Then this gap is called how much? I got a 2 zeta A divided by omega n. This is the gap. There is a still gap existing by omega n. So, even though there is a gap, there is an error. If we use one controller, we can make this error as a 0. We can make this error as a 0 by using PD controller. Sorry, not PD. Yes, PD controller. Last one. So this is the open loop transfer function. Now I'm going to get the closed loop transfer function. Closed loop transfer function already I told. If it is a unity feedback system, closed loop transfer function is numerator divided by numerator plus denominator. This is the numerator, denominator. If I add that one, you will get a standard second order closed loop transfer function. Omega n square, s square, 2 zeta omega n s plus omega n square. Then what is the order? Let me write here because I'm going to close this one. In this case, what is the order means? Order is always dealing with closed loop transfer function. Highest power of s in the denominator is order s. It is a second order. This is the data regarding second order system without controller. Now I'm going to put one controller in this forward path. If you put one controller in this forward path, otherwise if you put PD controller in this forward path, what are the elements is going to change? Change means comparing type number is going to change, or error is going to change, or order is going to change, or this omega n, natural frequency is going to change. I will check one by one. Yes, I'm going to use with, second order system with PD controller. With PD controller. I told controller is an external device which can be used in forward path or feedback path or both forward feedback in order to improve the system performance. Yes, let me take second order system with controller. This is input R of S. So I'm going to consider that PD controller. Yeah, I'm going to use that PD controller. This is a second order system. This is second order system. Then it is C of S. Signal direction is important. So already I told, if it is a PD controller, its a transfer function is. If it is a PD controller, its a transfer function is. Check it out. Yes, one second. So it's a transfer function is Kp plus Kd into S. So P means proportional plus a derivative of error signal. PD controller produce an output signal consisting of two parts or two terms. One is proportional to error signal. Other one is proportional to derivative of the error signal. Yes, derivative of error signal proportional to error signal. To remove that proportional constant, I'm using Kp. To remove that proportional constant, Kd. Yes, it is a U of t is output of controller. I told for any controller input is the error signal. Yes, it is an output. E is a input. Output by input is Kp plus Kds. I'm going to take Kp equal to 1, proportional constant equal to 1. I have to take, this is the gain of a PD controller. Gain means it is the block diagram. Input is E of t. Output is U of t. And its transfer function is Kp plus Kd into S. Now I'm going to assume Kp equal to 1. Kp equal to 1. Proportional constant, directly proportional constant is 1 in this problem. So its gain is, let me use a different color. Yes, if you assume Kp equal to 1, then its transfer function is 1 plus Kd into S. Input is error signal, E of t or E of S. It is U of t. This is a general transfer function, second order, omega n square divided by S into S plus 2 zeta omega n. Then assume, because I have to compare with the standard one, means I have to take a unity feedback system. Unity feedback system, negative. Unity means H of S equal to 1. Now I'm going to find, because I want to compare the open loop transfer function. For this block diagram, I'm going to find open loop transfer function is given by, again same formula, G of S, H of S. Again I repeat, G of S is nothing but total gain in forward path. This entire one is a forward path. From here to here, it is called forward path. G of S means gain in forward path. That means you have to multiply 1 plus Kd into S with the normal one. That equal to, let me write in next line. 1 plus Kd into S into omega n square. This all the derivations are not important. Simple statement is enough. PD controller is used to improve the transient response or improve the zeta. For that one, I'm giving the derivation part. S plus 2 zeta omega n. Now, what is the type number? Anyway, if you multiply this one, you will get a 1 plus Kd into S omega n square divided by S into S plus 2 zeta omega n. S, type number 1. Check it out. Number of zeros at origin. There won't be any change. Even though you are introducing PD controller in forward path, its type number is not changing. S type number equal to 1. Its type number also 1. There is no change in type number. I will ask. Because of if you introduce PD controller in a control system or in a second order control system, then its type number is changing, unchanging, maybe changing, like that I will set multiple choice. Yes, this is the derivation part. Type number is not changing. If I give the statement, this is meaningless as a faculty. That's why I'm giving the derivation part. Yes, first one is clear. Next one, I'm going to find Kp. Kp for this one with the PD control. Limit S tends to 0, G of S, H of S. Yes, this is the G of S, H of S. If you put limit S tends to 0, this is anyway 1 plus 0 into omega n square divided by 0. Something by 0 means infinity. Yes, I got here also infinity. Kp, yes, there is no change in. So for this one, you will get error is A by 1 plus Kp, that equal to 0. Yes, it is a 0. It is also 0. Steady state error 0. Steady state error 0. That means there is no change in a steady state response. I'm repeating, even though you are introducing PD controller, it will not affect the steady state error. Check it out. Is there any changes? Yes, it is a 0. It is a 0. Next one, we will check it out. Kv. Kv formula limit. Sorry, Kv, not Kp. Kv. 1 second. Yes, Kv equal to limit S tends to 0, S into G of S, H of S. If you put that, anyway, this, if you replace G of S, H of S, this entire one, this S and this S will get cancelled. Otherwise, let me write. Limit S tends to 0, S into 1 plus Kd S omega n square divided by S into S plus 2 zeta omega n. S will get cancelled. If you replace 0, it is 0. Numerator omega n square. Let me write. Numerator omega n square. Denominator is 2 zeta omega n. Check it out. Omega n, it gets cancelled. You will get omega n divided by 2 zeta. Then what about error? Steady state error is A by Kv. that equal to